And since we're just going to go with a 12-volt battery, so this is electrically, we're going to connect the modules in series and parallel, but thermally they're still going to be in parallel. It's just electrically we're going to connect two of them together in series, two together in series, two together in series, and then these are going to be in parallel. So let's see what that does for us. So we have a resistance of 2.5 amps plus 2.5 ohms plus 2.5 ohms is 5 ohms. 12 volts across 5 ohms, if I did the math right, is 2.4 amps. So 2.4 amps plus 2.4 amps plus 2.4 amps, I came up with 7.2 amps. So we're going to have 12 volts, a total of 7.2 amps, split into 3 different circuits. Our same delta T of 20 degrees, our current for each unit is 2.4 amps. 6 volts is going to be across this one, and 6 volts across this one, because it's a total of 12. It's a resistive divider, voltage divider. So from the graph, and I'll pull the graph up here, let's have a look. We said 2.4, 20 degrees, 2.4 amps. Try to, why am I, oh, because the camera's away. So we're saying that we're going to get about 10 watts of cooling power. 2.4 is about, if the line was 2.4, it'd be about in the middle, 20 degrees. So we're saying you can get 10 watts of cooling power. Okay, and we have 6 of them, so 6 times 10 is 60 watts. Our electrical load is 6 volts across each one times 2.4 amps of each module is 86 watts, or, well, 6 times, that's 12, a little over 12 times 6, so we got 86 watts total. Which means we still have 12 volts. Yeah, but this is for each individual one, so each individual one will have 6 volts now, because it's split 2.4 amps. The Q load of each of them is 10 watts. We can pull 10 watts of power through here, and we're going to dissipate 6 times 2 is like 12 watts of power per each module. 6 modules gives us a cooling capacity of 60 watts from the cold plate. And just because I could, because I wanted to have some ability to control the cooling capacity using 6, we can always go with a fewer number. We can go with 4 modules, or we can go to 8 modules, right? Depends on, you just got to start somewhere and see what the numbers look like. But if we were to put 1, 2, 3 in series, 1, 2, 3 in series, and put 2 stacks in parallel, we have 2.5 ohms plus 2.5 ohms plus 2.5 ohms would be 7.5 ohms across 12 volts. Should give us 1.6 amps through here. 1.6 amps plus 1.6 amps should give us 3.2 amps. So our power source needs to give us 12 volts at 3.2 amps. Over here, each module is 1.6 amps, 4 volts, right? 4 plus 4 plus 4 is 12. The voltage divider there. Our Q load from the chart is going to give us 5 watts of cooling power times 6 units gives us 30 watts total power, and then we have 38 watts to dissipate. So we said we can pull 30 watts and dissipate another 38 watts for electrical. So this Q load, we can either go a total of 30 watts, or we can go 60 watts or 210 watts, not by changing anything about how we configure that. all we're doing is how we're wiring the 6 units up. So, you know, by design and the grace of God, so who knows if this design's even close. What we gotta do is we gotta fire it up and start measuring some voltages and temperatures and heat loads, and see what our temperatures are for, like if we put a 30 or 40 watt light bulb up here, we know how much heat it's trying to draw out, and we can calculate or measure the temperatures and then go back to our graphs over here and have a better idea of what we're actually moving, and then refine our design. And for people that are experts, well experienced, seasoned professionals in thermoelectric cooler designs, they'll probably, I don't know, maybe not make fun, since I would expect them to be a professional, but they would express their concerns over a lot of glaring mistakes I've made in my assumptions and calculations. But you know, this is what I know and where I started, and I would learn by taking the next step and hooking it up. But these aren't my modules, they're the students. And they only have like 4 weeks left before they have to do their presentation, so it's kind of, I don't know how much they're going to get done. But for me anyways, I went through the exercise of trying to understand it a bit so I can provide some guidance to them, because it doesn't look like they have access to any other guidance right now. So I thought I would share that, because that's what I've been spending my time on in the last few days. Haven't been out on the sawmill doing trail work, been doing some indoor electrical thermal design, so that's where my retirement is.